All right, let's work a different one, but this is going to be a little different than the other videos. This one is going to be dealing with electricity. It's not going to be one of the traditional type of problems you see in related rates, but I really do like this problem. This one reads, the voltage V in volts, current I in amperes, and resistance R in ohms of an electrical circuit are related by the equation V equals IR. Suppose V is increasing at a rate of 1 volt per second and I is decreasing at a rate of 1/3 amp per second. Let T denote time in seconds. Find the rate at which R is changing when V equals 12 volts and I equals 2 amps. Okay, well, this seems on the surface like it's really bad, but it's not. We're going to write down what we have. I know that my EV, so my change in volts over time, is 1 volt per second. I also know di dt, my change in amperes per second, is going to be, and it's decreasing by 1/3 amps per second. And then it does give us an I at 2 amps and a V at 12 volts. One thing you may need to know for this equation is that an amp times a ohm is a volt. So our units will actually work out once we're done with everything, because what we're actually looking for is my change in my resistance over time. It is going to be an ohm per second. Once everything works out, you'd have to know this to be able to deal with your. All right, so let's work this problem. The one formula they gave us was that my V equals I. Yeah, my V equals my IR. I don't know what I was thinking. I know that formula. I don't know why I had to look at my paper. All right, so I have a dV di, so IV, so I'm okay. I'm looking for a dr dt, dr dt. So that basically means I'm going to take the derivative of this. So this side's pretty easy. It's going to be dV dt, derivative of v with respect to time. Here, I'm multiplying these, so I have to use the product rule. So I'm going to take the derivative of the first, so di, leave the second alone, plus take the derivative of the second, r, leave the first alone. All right, so from here, I know I need to have dr, so I'm going to solve this for dr, and I'm going to get dv over dt minus di over dr, all divided by I equals dr. All right, easy peasy lemon squeezy. All I got to do is plug things in. Now, here's where it helps to know that an ohm times an amp equals a volt. Because right here we have volts per second. So here I have an amp per second times an ohm. Well, then an ohm and an amp gives me a volt. So this is actually volts per second. So my units match up. And then here, my I is an amp. So I'm going to end up getting an ohm per second with my units. So my units work out perfect. So now I'll just plug everything in and just solve. All right, so my dV dt is 1 minus my di dt is a negative 1/3. My r, oh wait, I ain't got r. Well, luckily I have V equals IR, and I have a V and an I, so that's easy enough to solve for. So I can say V equals, not V, 12. 12 equals I, which is 2, R, therefore R is going to equal 6, so that's easy enough, times 6, all over my I, which is 2. This is going to give me my dRt. Well, this comes down to being 1 plus 2 over 2 is my dr dt. Therefore, change in my resistance with respect to time is going to be 3/2 ohms per second. And you're done. I like the problem because you have to use the product rule here and then still solve. And it gives a different variety of type of problems. Electrical circuits, pretty common in math, and whether you're an engineer or just a math major, you're going to have to do a lot of stuff with electrical circuits. Very interesting, not terribly bad. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.